me which one is your answer, I can't help you. Okay. So now I'm going to take this problem and step it up a notch. What is the probability that a male is shorter than 71 inches? So, and again, remember, this is just an extension of what we were talking about last time. So remember, we said the average male height we're taking to be 68 inches, and the standard deviation we're taking is 2. Now, first of all, how do we write this question down in notation? P, yes. Okay. P parentheses what? Yes. Yes, but other way around. Right. A male is shorter than 71. X less than 71. Okay, and how do we know this is X and not Z? It's asking for? Yes. Yeah. This is a data value. This is not about a Z-score. Yes. Okay. So that's the first thing. So now how can we solve this problem? Well, we're going to use Excel at some point. So we have a data value. So what's the first thing that we're going to have to do? Okay, let's draw a graph. That's a good idea. Okay. Actually, yeah. Okay. Alright, here's a graph, and what do we label on the graph? Okay. And 0 goes in the middle for what? Z. What else can we label? And where does 71 go? Yes. To the right of 0? Where else could it go exactly? Here's another thing to ask. What other number goes in the middle? The mean. And what's the mean? There you go. And 68 is what kind of value? It's a data value, so we label that with X. So now, where does the 71 go? To the right is 68, exactly. Yes, but you see my point. They shouldn't be confused. You don't confuse your Z values with your X values. Okay. So now we can still mark something off on the picture. What can we mark off? Yeah. Yes. Why? Exactly. Go back to the question, shorter than 71 inches, in the notation, less than 71. So what we're looking for is this area. All right. So that's just the question. Does everyone get the picture?
Yeah.
Okay. So the next thing is, what is the next thing that we need to find? Yeah. Next thing we're going to do is find the Z-score. Because once we know the Z-score, what can we do? What have we been doing for the past bit? Yes, once we find the Z-score, we can then find the probability. Okay. So, let's relocate this. Here. Okay. Oh, actually, I'm not doing it. Okay. So here's the first thing. So the first thing we need to do is we need to find the z-score. How do we find the z-score? Yes, and how do we do that? Yes and yes and yes. I'm sorry, yeah, Yasmina, go ahead. Yep. And this is coming from a formula. How does the formula go? Right. Data value minus the mean over the standard deviation. And this works out to 3 over 2, which is 1.5. So, as soon as we know 1.5, what do we do with that? Fill it in on the picture. That's the z-score. Okay. So now that we know the z-score, what can we do? Use Excel to get the probability. And how do we do that? Norm S dist of 1.5. 0.9332. And is 0.9332 the answer? It is. I just want to make sure everyone knows that. Is that the area that we're looking for?
Yeah.
If you look at the picture, is that the area that we're looking for?
Yeah.
Yes. That's the area we shaded. That's how we keep track of what we're doing. Okay. Any questions about this problem and how it goes? This is the main basic sort of problem for how to do these calculations. Good? Good? Okay. So what we're going to talk about pretty much for the rest of the period are problems similar to this one and how we're going to use the technology to do it. Now, one thing that I want to show you next is we can use something other than Excel to do these problems. So what do you mean?
Like the same way, like when we first started this deviation, when we were doing it with whatever.
Do all the calculations, blah blah blah, square it, square root, all that.
Yeah, no, yeah. Is it still like you have to subtract the number?
Right, to actually do the calculation in order to find the standard deviation.
Yeah.
Yes, but here I'm telling you what the standard deviation is.
Oh. Okay.
So do you have to calculate it?
Yeah.
No.
But on the homework they asked for the standard deviation.
They said to calculate the standard deviation?
You have to find the standard deviation.
Okay.
And I was like, no.
Okay. Okay. I may or may not have mentioned this last time. Okay. You no longer have to do standard deviation by hand. So let's say, let me clear this out for a sec. Okay, so I believe I mentioned this, but just in case. Yes, I know I mentioned this, but let me repeat it. If you have a bunch of data, how do you find the standard deviation? Okay. Well, first of all, how do you find using the technology, how do you find the mean? Or how do you find the average? Equals average, open parenthesis, highlight your data, return.
So the next step is going to be
Yes. How do you find the standard deviation? Equals STDEV, open parenthesis, highlight your data, close parenthesis, return. And there's your standard deviation. Is that good? The command for average is average, and the command for standard deviation is STDEV. Sorry? How do you find the variance? Take the standard deviation and square it.
So you could just take square result and just type it in. 144.0854 squared. Okay. So that was a quick one about, yeah. So from now on, I presume you would find standard deviation that way. So it should take you about 4 seconds. Okay. So now returning to our regularly scheduled topics. All right. Okay. So first thing I want to show you is other way. So to do what we've done, given a z-score, find a probability. We know how to do that with Excel. Now I'll show you how to do that using Statdisk. So what is Statdisk and where can you find it? Statdisk is just it's a software program specifically designed for doing basic statistics. And you can find it if you go to my website. There's a link that says software. And you can just download it from there. Okay. And again, you'll have a chance to play with Statdisk when you're at a computer. Alright, so that being said, how do we do this? Once you open Statdisk, you click Analysis, Probability Distribution. Now which distribution are we interested in? Normal distribution. Now in this last problem, what did we have that we should now type in? The z-score. What was the z-score? 1.5. Now all you do is click Evaluate. Now it tells you lots of stuff. What is it that we need for this problem? Area to the left is right there. Now for the publisher's website, you should get used to writing your answers to 4 decimal places. And to 4 decimal places, what is the answer? Nope. Right, because you have to round it. So just remember that you're rounding, not cutting off, if you want to get it right. Okay. Notice Statdisk is also helpful because what does it also tell you? Which might be useful for another problem. It tells you the area to the right as well. Okay. So it also tells you two-tail and central, and we'll get more into that later. Okay. So, some people like using that. All right. Now, so that's how to use Statdisk. It pretty much explains itself. Once you remember where to go in the menu, it explains itself. Okay. So I happen to think Statdisk is easier. Maybe you agree. So why did I bother showing you Excel? Excel is very powerful. You have to know how to use it, however. So what I'm going to show you is, in this last problem, the question was, I gave you a data value,
and then I said find the probability. Now from the data value, what did we have to do first? Find the z-score. It turns out that with Excel, you can skip that step. So now notice, what did we need to know in order to do this problem? We needed not just the data value. What else did we need to know? Well, we solved for the z-score, but in order to solve for the z-score, what did we need to know? The data value, what else? The mean and the standard deviation. So it turns out that if you use Excel, you can just punch all those things in if you know the proper command. And the proper command is norm dist. Exactly. Because what does the S stand for? No. The S stands for standard. So when we talk about the standard distribution, the normal standard distribution, that means in terms of z-scores. But normal distribution just means it could be not just z-scores, but it could be anything with a normal distribution. So norm dists, parenthesis, what do we need to type in? X. What does X stand for? What does the X stand for? No. What does X stand for? Data value. In this last problem, what was our data value? 71. Comma. Mean. What was the mean? Comma. Standard deviation was 2. Comma. Cumulative. Always put true. Don't ask. And when I hit enter, what is it going to say? There you go. That's one way to do it, yes. Sorry? Yes. It tells you, notice that Excel tells you what order to put everything in. Excel is at least helpful in that respect. And don't forget your commas. So let's just so we get a little practice using this, let's answer this question. What is the probability that a woman is over 69 inches? So what's the first thing we do? Draw a picture. Absolutely. So what do we label on the picture? For what? For Z. What else can we label? 64? Where does 64 go? Yeah. This is women. So remember, for women, the average height, we said, as I wrote over there, is 64. Alright. And what else should we mark off? 69. And what else do we mark off? Nope. We never label the standard deviation, we just keep it in mind. Okay. Do we know it? No, then we can't mark it off yet. But what should we mark off on the picture? We marked off 69 and then do what? Shade which way? Y to the right? Over. There you go. Okay. So now, normally what would we do at this point? Normally we would find the z-score. Remember, I'm showing you we can use Excel to skip that step. So we write equals norm dists, and now we put in the stuff. So what is the x value here? 69. What's the mean? Next. 1.5. And true. 0.9996. So the answer is 0.9996. Yes, Edward. Exactly. 0.9996 is not your answer. Look at the picture. Where does 0.9996 go? Yes. 0.9996 is this area to the left. But is that the area that we want? No, look where we shaded. So what we want is the opposite area, so we have to do 1 minus. Okay, what's the difference? Right, and what's the other difference? Norm at what is the S stands for standard. So when you do norm Statdisk, what kind of value does it ask for? It asks for a z-score. When you do norm dist, what kind of value does it ask for? Or which is also known as a data value. So that's the difference.
So that's data value, like 0.0004.
0.0004 is not a data value. Okay, good question. What is it? 0.0004 is what kind of value? It's the answer value, right? But what kind of value is it? It's a probability, right? In fact, if you like, you can even label up here probability, which is the same as area. So your picture is going to have x values, z values, and probability values.
So you could convert from into fractions, because usually, like, well, when you learn probability, like, you have to like 1 out of.
Right.
That's not a because I'm just seeing it like that.
Right. So that's actually very true. I remember the way we started off doing probability was saying it was a fraction. Okay. But then remember the next thing I said. I said when you write down a probability, the easiest way to write it down is a fraction. However, we're going to be doing calculations with probability. And when you do calculations, it's easiest to write it as a decimal number.
It's always, yeah, okay.
So that's all. So and again and I know it's sort of hard. There's no like 1 out of 4. There's no intuitive meaning to 0.0004. The only thing that you can get out of that is that remember this is all out of 1. The total probability is 1, and that's the best you can think of.
It's easier to solve, like it's easier to look at.
Yes, you're right. Okay. Okay. And there's one other way. I don't recommend it, but I'm going to show it to you, primarily because, well, for 2 reasons. Number one, well, let me show you what it is. In the appendix, there is Appendix A of the book. There are these tables. So we need this table. So this is a table of values. What this does is for every z-score, it lists the probability value. Or in particular, it lists the area to the left. So notice that in the last problem, what was our z-score? Oh, I'm sorry, right. So the last z-score we found was 1.5. So let's find that on the chart. So here's how you do it. Z-score is on the outside of the table. So how do we find 1.5? We have to be a little careful. This table lists z-scores to 2 decimal places. So we've got 1.5, then we need to make it 1.50. The way you do that is taking this 1.5 and pairing it with the 0. So if you pair the 1.5 with the 0, you find that value, which you see is 0.9332. Notice that if you're looking up the z-score of 1.51, you'd have the 1.5 and the 1, and then that would give you this probability value. Alright. Now I show you the table for 2 reasons. One reason is that the textbook and the explanations often assume that you're using a table, and I wanted you to know what the heck they were talking about. The second reason is that before there was technology, this is what people did. Now, are you going to choose to do it this way? If you have a computer available, are you going to do it this way? Probably not. And I don't recommend it either. I just want you to appreciate how lucky you are. Alright. So that's it. Anyone who wants to use the table, please feel free to use the table. I'm just not going to talk about it in class. Sorry?
On your website?
It is, first of all, it is in the textbook, so you can. So if you're online, you can flip through the textbook to find it. Second of all, I've made it a separate handout, and you can download it from my website. Okay. So those are the three methods. Typically, I'll use either Excel or Statdisk in class. Show you how those things are done. Okay. Next. So far, what have we done? I've said, here's a z-score, find the probability. Or, here's a data value, find the probability. Now, we're going to go backwards. What does it mean to go backwards? Exactly. I'm going to give you the probability. I'm going to say find the z-score or find the data value. So how do we do that? Okay. Now, a couple things also. In addition to talking about probability, we could also call this the percentile. Now, very quickly, I want to explain why saying probability and percentile are kind of the same thing. What z-score is above 90% of your data? Well, what the heck does that mean? Well, I'll draw it on the picture, and maybe you can then tell me why this is the right picture for that question. Okay. Great. Why is this the right picture, and what numbers should I label this with? Okay, what do we label with 90? Kelly? The shaded area. Right. And it's not just 90, it's 90%, which is 0.90. So this area is 0.90. And notice something else. Which z-score are we looking for? The z-score where the bar is, because that z-score is above 90%. Does that make sense? Albana, does that make sense? No? Okay. We're looking for this z-score. Notice that that z-score marks off the bottom 90%. So that z is above 90% of everything else. Yeah? Okay. So the question is, how do we find that? Well, we've got to go backwards. And in math, we have a word for backwards. Do you know what it is? In math, the word for backwards is inverse. So before we were using norm S dist. Given the z-score, you find the probability using norm S dist. So to go backwards, norm S inv. So in Excel, equals norm S inv, and what does it ask for? It wants a probability. So what number do we punch in here? 0.9 or 0.90 or 0.9000 or whatever you like. And it gives us that number, 1.2816. What kind of value is 1.2816? It's a z-score. That's it. And it's our answer. Yep. Okay. So we have a request to do another one, so let's do another one. Alright. Alright.
Okay. So let's find the z-score at the 85th percentile. How do we do that? So you draw the picture. And how do we label it? 0 in the middle for z, and... Sorry? And how do we do that? Yeah, we're shading in an area.
What z-score is above 90% of your data will be the same thing as what z-score is at the 90%?
Yes, because that's what percentile means. Remember what that's what percentile means. Percentile means above such and such percent of your data. Okay. So now, and so what else do we know? We know that this represents an area of 0.85. So now how do we find that z-score? Equals norm S in of 0.85. 1.0364. And that's your answer. Let's fill that in on the picture. Okay. So there you go. Good? All right. Next. What female height is the 90th percentile? So how do we do this? First we draw the picture. Okay. And now what? 0 is in the middle for z. And what else can we label? And what's the mean? Yeah, the mean is 64. Well, what are we being asked to find here? Are we being asked to find a z-score? No. We're being asked to find a data value. So what the mean is very important. Because we're talking a data value, we're talking about x values. So for x, we need to know what value is in the middle. Okay. So what else can we mark on the picture? We never mark standard deviation on the picture. We just keep it in mind. Yes. Exactly. This shaded area is 0.90. And so what do we need to find now? Yeah. We need to find the height. So what's the next thing that we need to find? Yeah. Find the z-score. And what's the z-score? Yeah, and didn't we just did this? We need to find the z-score, but we just did that in a separate problem. So the z-score that we need is 1.2816. And now what do we need to do? Yes, but you're giving me the formula for z equals. And we're trying to find x, and we have a formula for x equals, and what is it? No, not because it's on the right, it's always plus. Right. Z may be negative, though. It's mu plus z sigma. Now, what's mu? Plus. What's z? Well, we just found that, right? Okay. And sigma is 1 point. So you work this out, 64, actually. No. This is 64 plus 1.9228. 65.9228. And by the way, this is a data value, so it's 65.9228 what? What are we talking about? Yeah, female height, this is inches. And as a final touch, we should put that value on the picture. Where does that go on the picture? This value, where does this go on? 65.9228, where does that go on the picture? Okay, we'll go back. Where does it go? 7 who what? Somewhere. It goes somewhere very specific. Yep, it goes right here. Because this is the height that is associated with that z-score, with the z-score of 1.28. 65.92. I ran out of room, so that's what I'll put. Okay. So Violet, which part? Oh, because we did that 5 minutes ago. Sorry? How did we, so we said what z-score is above 90%, so we used norm S in of 90%, and that gave us 1.2816 for the z-score. So that one said the 90th percentile for z, and this one said what is the 90th percentile for female heights. But to find the z, we're still finding the z for 90%. So it's the exact same thing. So the z-score is 1.2816. We can do it again, but it's the same thing. Sigma. Standard deviation. Sorry? Yes. Yeah. So good? Okay. Albana question? Alright. Any questions? Any questions you want to ask? Okay. All right. So this is oh, and one more thing. So in this last example, what did we have to do? I said what female height is the 90th percentile. So basically, you were given the probability, and then what did we do? Found the z-score, and then we use the z-score to find the height. Well, once again, Excel gives us a way to skip over the z-score step. So instead of using norm sinv, we just use norm inv. And now we have to enter probability. So in this last problem, what was the probability? 0.90. Comma, mean, what's the mean? Comma standard deviation, which is 1.5. And when I hit enter, what am I going to see? There you go. Yep. Oh wait, that's not 2, 3. So what we've seen is a lot of different procedures, a lot of different steps, and everything's related. What are all these things and how are they related? Is the question that's on your mind right now. And here's the answer. So, this is your handy dandy chart, which I made to help you understand the relationship between everything. So based on this chart, for example, if you have a data value and you want a probability, what can you do? You can use no. You can only use one of them. Right. If you have a data value, you want to get a probability, you use non-guess. If you have a data value and you want a z-score, what do? Yes. Which is d equals x minus mu over sigma. It's a bit small, but you can see it in the notes. So this tells you everything. Okay. This is page 48 of the notes. I presume you'll be keeping this handy. Sorry, there's also one thing which I neglected to show you, which is the last bit, how to use Statdisk for that. So I'm going to come back to this in a second, the chart. I said you can use norm sinv to go from the z-score to the to go from the probability to the z-score. We can also use Statdisk for that. So let's do that 85th percentile question. Analysis, probability distribution, normal distribution. Now, what do we know? Do we know the z-value? No. Do we know the cumulative area to the left? Yes, and what is it? 0.85. Click evaluate, and what do we need? The z-value, and there it is. What's that? Okay, then use this one. Okay, good. Yeah, a lot of people like using Statdisk because it's easier. Some people like Excel because it can do more. Choice is yours.
I have a question.
Yes.
Can you tell you what Microsoft works?
Yes.
Because I don't have Microsoft Works on my computer, and I have a spreadsheet that looks a lot like Excel.
Yes.
But it's not giving me the same option.
It won't. You'd download OpenOffice.
And you can do it in OpenOffice, all these things.